Welcome to Pure One, Chapter 11, where this chapter will be looking into vectors, bringing you from GCSE vectors to A-level vectors. Same magnitude, same direction. Pun intended, get it? Anyway, we'll start with some basic vectors where we look into what you've learned before, bring you and then all the way to different things about solving geometric problems. To be honest, some of the questions or some of the things you might actually have done in GCSE, usually very hard questions of vectors. But anyway, so let's go through. So basic vectors, you should know a lot of them. A vector has direction and magnitude. Opposite to a vector is scalar. To be honest, they are not directly opposite. They just have different functions. Scalar, like a multiple, has magnitude, size. So magnitude same as size, okay? Or length. Or, we talk about how long, how big, how, like for example, magnitude of earthquake, etc. Whereas a vector has direction and magnitude. So are they opposite? They're not opposite. It's just what vector has direction extra. So where a line usually is a scalar, where a vector with an arrow is a vector. A vector with an arrow is a vector. Anyway, opposite. So for example, in this one, you can see PQ. In here, you can see a little arrow. It might be a bit small, but you can make it bigger. So PQ, that's P to Q. Okay, so P to Q. And this one is QP, Q to P. Right? So we know the order of the letters matter because PQ means P to Q. And if PQ equals A, then QP equals negative A. Now, you might be thinking, what is this regular line underneath it? A regular line, essentially, it means this variable, this letter is a vector. Specifically, is a vector. So when it's in print, sometimes they will bold it to tell you it's a vector. Anyway, so given example, AB is A and BC is B, find AC. So AC means we want a journey, want a route from A to C. Okay, so from A to C means we can do from A to B and then from B to C. Now, note one thing, the starting letter A should match with the same letter in here, and the ending part of the vector C, the end part of the journey, should match up with this last letter of the equation. So A, B plus BC equals, so we know, oops, A to B is A, B to C is B. And that's it. That's an easy. So example, if PQ equals A, M is a point of PQ that divides PQ in the ratio of 2 to 1. Find QM. Now, before we start, can you think about where the point M is? Because of the look at the ratio. Is M closer to P or M closer to Q? So M divides PQ in 2 to 1. That means M should be closer to Q because the part of MP should be 2 to 1 to the part of PQ. MQ. So M, let's say, is roughly here, maybe. Okay, roughly. So 2 to 1. Okay, so as a fraction, it's 2/3. So find QM. To find QM, so now look at this. QM is, be careful direction. QM is that direction. So QM is 1/3 of QP. Now QP is negative A, so it's 1/3 of negative A, which is same as negative a third A. That's QM. Okay, so QM is not a third of A, it's negative A because we're going in a negative direction. So be careful with the direction. Example practice. Okay, if you're confident, you can have go these questions really. Depends on how good you are with vectors. But if not, I can go for this. Okay, if you want to pause the video, then have a go. Okay, if not, I will just carry on. So if QP, okay, equals A and QR equals B, QS equals C, RT equals D. Find PS. So from P to S, okay, so from P to S, part A, I'm not doing here. P to S, I can do from P to Q plus Q to S. P to Q is negative A because we're opposite direction. QS is C, so minus A plus C, right? Part B. RP, so R is here, P is there. So RP, we can go this way. R to T, T to P. However, we realize TP is missing. So probably the easier way probably is R to Q, Q to P. Okay, so R to Q plus Q to P. R to Q is negative B, Q to P is A. So minus B plus A. Question C, PT. P to T. Now we need P to T. So from P to T, we can go from P to Q, Q to R, and then R to T. So P to Q is negative A, Q to R is B, R to T is D. Okay, and the last but not least, question D, T to S, TS. So from T to S, now remember we now have T, we now have PT. So what we can do is to go from T to S, we can go T to P, and then P. Oh, we can't do. Yeah, we can do PS because we go from part A. Okay, so T to P. So TP is the negative of PT, which is negative of minus A plus B plus D plus PS. PS is minus A plus C. So this part is from part A. So from A. Okay, right. So minus A, so minus A is A, minus B, minus D, plus minus A plus C. So A minus A is gone. So minus B plus C minus D is the final answer. Okay, right. So next, if two lines are parallel, then one vector will be a multiple of another. So we should know this. For example, in here, if we have PQ, let's say PQ, okay, is A, okay, and we have another line which is should be parallel, okay, AB, let's call it AB, okay, parallel. So if PQ is parallel to AB, then AB will equal to a lambda of A. So lambda is just a multiple. So multiple. Okay. So for example, if AB is half of PQ, then lambda is a half. Okay. Um, yeah. So also one more thing. If two lines are equal in length, then the magnitudes are equal. So okay. So one more. If PQ, if length of PQ equals AB, then we use this, okay, this line here, this bar symbol means magnitude equals AB. So we'll talk about this a bit more later, but just write down. Okay, so given PQ is 2A plus 3B and AB equals 6A plus 9B, prove that PQ and AB are equal. So if we look at numbers, have some numbers and 2, 3, 6, 9, they look like AB could be factorized. So AB, if I factorize 3, I get 2A plus 3B. So 2A plus 3B is the same as PQ, so 3PQ. So AB equals 3PQ. Therefore, AB is parallel to PQ. And in fact, AB is actually 3 times longer than PQ. So done. Okay, so all we need to do is to show they have the same vector. Right. So practice question 2. OACB is a parallelogram. MQ and P are the midpoints. So these are midpoints of OA, AC, BC, and OB respectively. Vectors P and M are equal to OP and OM respectively, expressed in terms of P and M the following. There are quite a lot of them. If you want me to do that, I could do the first one with you. Question A, to find OA. OA is the same as M plus M because they're parallel, that's double. So OA essentially is just 2M. Okay. So pause the video, have a go at the rest of them. When you're ready for the answer, you can press play. So here are the final answers. Remember they're parallelogram, so all the little lengths, MD same as will be same as OP, same as PB, same as DN, QC, AQ. These are all P's, and OM, MA, those ones that are pointing upwards, sort of not upward direction, they are all M's. So here are the answers. Okay, right. Practice question 3. ABCD is a trapezium there, with AB parallel to DC. Where so let's draw it out. Okay, probably draw the shape. So let's draw it out. So I think probably A, B, C, D in here. So AB is parallel to DC, makes sense. Where DC is 3AB. Okay, M divides DC such that dm to mc is 2 to 1. So that means it should be closer to c because dm is longer. So m is probably here, 2 to 1. If AB is A and BC is B, find in terms of A and B, AM. Okay, so to find AM, right, to find AM in here, what we can probably do is from A to M, what we can do is, now we don't know what's AD for now. Um, what we can do is we can do A to B, B to C, and C to M. So there's different ways we can do this. Okay, so right, let's do it. Question A. So AM equals AB. Oh, actually, it's a practice question. Sorry, it's a practice question. Didn't realize that. Pause the video, have a go at the question. When you're ready for the answer, you can press play. So here's the answer. Actually, part A is the hardest part of the whole question. I forgot this was a practice question. Anyway, but if you struggle to do A, have a go B, C, D first, and then come back to this page again. So question A. To find AM, we can do AB plus BC plus CM. However, we don't know what CM is. CM is actually a third of CD. Now, note the direction of the letters in here. C to M is a third of C to D, not DC. Okay, because C to M is going in the left. Think of it as in left position, going to left direction. So therefore, it's a third of CD in the left direction as well. So it will be CD, which is negative 3A, because we know DC is 3AB. So DC is 3A, so CD is negative 3A. A third times negative 3A is negative A. And so AM equals AB, which is A plus BC, B minus A, which is just B. So in fact, AM is actually parallel to BC. But obviously our diagram, we don't know that. So we drew our diagram sort of wrong. If we position BC a bit more wide, then it will be the correct. Anyway, but diagram doesn't matter. So therefore, the diagram is not always the most accurate. It just gives us a ballpark figure where the terms are. So doing calculation sort of give us a better idea where B, how to draw a diagram. If we draw again, we probably now know BC is parallel to AM. Anyway, BD is BC plus CD, so BC is B, CD is negative 3A, so B minus 3A. MB is M to C, C to B. MC is a third of 3A. Now this time M to C is going to right direction, so going to the right. Therefore, it's a positive 3A. So a third times 3A is A minus B. DA, DC plus CB plus BA, so you get 2A minus B. All right. Yeah, that's it for 11.1, basic factors.